So the purpose of this video is to check your work on our second graph interpretation. And we had an important I wonder question here, and it's on this slide. Are carbon dioxide levels and historic temperatures, are they actually connected? And so here's what we know so far. In recent times, Earth's planet is definitely heating up, but we also know over the last 450,000 years, based on ice core data, that Earth has gone through these cycles where they've had cold ice ages and then interglacial periods. So it made us wonder, are we just currently in an interglacial period, and maybe 50,000 years from now, we might be in another ice age? Well, with our global warming game and puppet show, we've learned that carbon dioxide is a greenhouse gas, the main, not the only, but the main greenhouse gas because of its ability to trap heat. Now, the fancier way to say that is carbon dioxide can absorb infrared photons. Remember those red beans in the global warming game were standing for infrared photons. So what we wanted to do with this is to interpret two graphs, and here they are. The top graph here, and this would be question number 1, for your graph interpretation. It's asking you for question number 1, just what the X and the Y axis were here. And so on the first one, the X axis is showing years before present, or you can just have years, and the Y axis is showing temperature. So you can see when you look at this graph that we are currently in a warm period. And so the question of how much colder has it been than now? So if you look at our current temperature, it's about 60 degrees Fahrenheit on average across our planet. So then if we want to know how much colder, we have to go to the lowest point and subtract. So I have the answer of 17 degrees. So we're currently in a warm period. It's been 17 degrees colder on our planet in these past 130 or past years. I'm sorry, I misspoke there. Let me look. Past 160,000 years. So now what about, has it been, how much warmer has it been than now? Well, to do that, we still have this current 60, but we find the top temperature. Do you notice it doesn't go quite to 65? So that's why I said it's been 4 degrees. So 64, the highest temperature, minus 60. And then the next question was, well, when was it warmer than now? And the answer to that is about 130,000 years ago. So we see these answers to the first 4 questions. Now, the next set of questions asks you to interpret the bottom graph. In the bottom graph, at first glance, you might be like, oh, it's the same graph. Well, no, it really isn't. Notice on the x-axis, we still have years before present, but here is something totally different. This is the concentration of carbon dioxide in parts per million. So for every 1 million gas particles in our atmosphere, how many of them are carbon dioxide? That's what we mean by the unit parts per million. So for question 5, you should have years before present and then the concentration of carbon dioxide. And then question number 6 is really the most important one here. And it's, what do we notice about the relationship between global temperature and carbon dioxide? So the way I wanted you to complete that statement is this: if there is a lot of carbon dioxide in the atmosphere, then the temperatures are high. Let's look at that together. So if there's a lot of carbon dioxide in the atmosphere, right here, the temperatures are high. You could have also said when there's little bits of carbon dioxide in the atmosphere, the temperatures are low. Do you notice that we could almost place these graphs on top of each other? And so the question that is left for number 7 is, well, what's causing what? Are the higher, right? Just because we see a connection or a correlation doesn't mean a cause. So it makes us go to this next step. Are the high temperatures causing high carbon dioxide, or are the high carbon dioxide amounts causing the high temperatures? And we know that that answer is B, because we know scientifically proven that carbon dioxide can absorb infrared photons, which is science way to say can trap heat in the atmosphere. Now, I wanted you to see just a couple of other little things that weren't really part of your questions, but please continue to listen. So how do they even know carbon dioxide levels a long time ago? Check that out. This is a sliver of an ice core, and can you see that there are little bubbles that are trapped there? Not only do the thickness of the layers of ice core tell us ancient temperatures, but ice cores also have gases trapped in them, and scientists can analyze to find the concentration of these gases. Ice cores are a very valuable resource for us finding out about our planet. Now, another little connection that I have for you is this. Remember, in our plate tectonics unit, we traveled to Mauna Loa. Mauna Loa is that shield volcano in Hawaii. And there's actually an observatory that I drove past, and we actually flew over in a helicopter on the tip top of Mauna Loa. And you might think, well, why would they put it there to collect global carbon dioxide levels? Well, it's really in the middle of nowhere, right? So Hawaii's smack dab in the middle of the Pacific Ocean. You get on top of this mountain and you're getting realistic carbon dioxide levels. So since the 1950s, this is where the official carbon dioxide levels have been kept. Now you'll notice we see this trend of an increase in carbon dioxide on our planet, but isn't it kind of odd when you look at this that you have these little zigzags, right? This up, down, up, down, up, down. And so here's the reasoning for that. I will just show you. If you check this out, do you notice how the carbon dioxide amounts are up in the winter and then they drop in the northern hemisphere summer? This happens every year because of photosynthesis. When plants are actually like plants that lose their leaves, when they're actually doing photosynthesis in the summer, they absorb the CO2. In the winter months, there's always more carbon dioxide because there aren't as many plants doing photosynthesis. So that's why scientists look at this best fit line. So now let's go back and look for a sec here. Okay, in 1998, the parts per million of carbon dioxide was like 365. Now, 2009, it looks like, up to 385 parts per million. Now, this is the most recent data I could find. This is from January 10th of 2021. Check that out. So we as a planet, it made pretty big news when we passed the 400 parts per million level of carbon dioxide. So what we see on our planet are carbon dioxide levels in recent decades shooting up quite a bit. And that concerns us that it's causing issues with global temperature. And again, we know this about past global temperatures because of ice cores. We know the present carbon dioxide because it's monitored on the top of Mauna Loa in Hawaii.